writing equations of sine and cosine graphs. So if we look at a curve and we're wondering, is it a sine wave or a cosine wave, one of the first things we should do is draw in the midline. So that now we can see, all right, this curve is starting at the midline and then it's going up to its maximum. So that's the sine function. Whereas over here, if I draw the midline for this one, we can see it's starting up at the maximum and then coming down, so that's the cosine function. Because remember, the sine of 0 degrees, the sine of 0 degrees is 0, and the cosine of 0 degrees is 1. So sine starts down the midline, cosine starts up at the maximum, and then comes down. All right, so if we look at these next two, if we draw in the midline, we see it's starting down at a minimum, which tells us it would be like a negative cosine function. It's just reflected vertically. Whereas this one over here is also reflected vertically, but it's starting at the midline, so that would be a sine function. Because today we're going to be working on writing the equation. And so we've got to, first of all, identify, is it a sine function we're writing or a cosine function? So again, always start with your midline, draw that in first. So we see the midline down here at y equals -3. And then the midline, how far up is it? Make sure to take a look at the scale. So it's 2 blocks, but 2 blocks is just 1 unit on this scaling. So amplitude is just 1. For the period, let's trace a whole cycle. So if we start up here at a maximum and we come to another maximum, that would give us the period. So it takes from 0 to 3 pi to complete 1 full cycle from maximum to maximum. And since we're starting at a maximum, we would use a cosine function for this. Frequency, remember, is the reciprocal of the period, so it's 1 divided by 3 pi. All right, this next one, again, always start with the midline. So here's my midline. We're starting down on a minimum, so we could use a negative cosine to model this one, but let's fill in this information. So y equals -2. For amplitude, it goes from -2 up to +1. So that's 3, amplitude of 3. Or you could see it and you start from the midline 2 down to -2, down to -5, so that's 3 units. Period. So if we start down here at a minimum and we trace until we get to another minimum here, and so that's at 4 pi. So the period this time is 4 pi to get from a minimum to another minimum. So the frequency would be 1 divided by 4 pi. All right, on our next page, again, start by drawing in that midline. Oops. And so we can see that's at y equals 1. And so from there, it's from 1 to 4, that's 3. Or you can see from 1 to -2, so that the amplitude is 3 for the period. So if we start here at the midline and track, so there would be 1 complete cycle, so we would use a sine function for this one. It's negatively oriented, so we'd have to use a negative in the front of it, but the period goes from 0 to 4. And then vertical shift, since the midline is up at 1, that's your vertical shift. The midline gives us our vertical shift. All right, so if we draw in our midline here, and we count, we're up 2 blocks or down 2 blocks. So amplitude is 2 for the period. So if we start here at this maximum, so we get back to another maximum, that's right here. And so if we have And this is pi. That's 1, 2, 3, 4, 5, 6 blocks over. So every single one of these must be pi divided by 6, or pi 6. So that would be pi 6. Next one would be 2 pi over 6, which reduces to pi over 3. Then it'd be 3 pi over 6, which will reduce to pi over 2. Then it'd be 4 pi over 6, which is going to reduce to 2 pi over 3. So there's our period, 2 pi divided by 3. And the vertical shift, the midline, is up there at 3. All right, so remember that the period is always equal to 2 pi divided by the b value. And it's the b value that we find in the equation, not the period. So how do we find the b value? Well, if you would think about solving this equation, we could multiply both sides by b. So we have b times the period equals 2 pi. And then if you want to solve for b, you'd have to divide by the period. So we see that b is always going to equal 2 pi divided by the period. We have to do the math to find that every single time we need to write an equation because, again, it's the b value that goes into the equation, not the period. So if we take a look at this next example, let's start by drawing in that midline. So midline, remember, is your vertical shift. And so vertical shift for this one is 5. The amplitude, well, from that midline at 5, it goes up here to 8, so the amplitude would be 3. If we trace, so we started at midline, gotta go low, high, back to a midline, we see that our period equals pi. So then to find our b value, we gotta take 2 pi and divide it by the period. And so we get 2. You can also just, if you remember that the period is 2 pi over b, you can always solve for it that way as well. And then say, okay, 2 pi equals b times pi. So then divide by pi, b equals 2. One of those ways, so either just memorize that b is always 2 pi divided by the period, or if you can only remember that period is 2 pi divided by b, then just set that equal to what your period is and solve. Do your algebra, multiply by the b, divide by whatever you have times the b, you get b by itself. But that's the number that we're going to put in the equation, not this one. This does not go into the equation, only the b value. All right. So also, I see that we start at the midline, but then we come down to a minimum. So we're going to make it a negative sine function. So we're going to say y equals -3, the negative to reflect it, and then the amplitude of 3. Sine, our b value is 2x, because there's not a phase shift here, and then plus 5. Now, if you wanted to, though, there are different ways you could view this. So you could view this as a positive sine function that's just had a phase shift. So if we view this as the start of our positive sine function, then we can modify this a bit and say, okay, let's make it a positive 3 out front, sine of 2, and then if this is our starting point here, that's a phase shift of pi over 2 to the right, so we'd say minus pi halves inside with the x, and then plus 5. That would give us the same equation. We could even view this as a cosine equation. So amplitude is still 3, cosine b is still 2. We just need to give it a phase shift. So a cosine function is going to start at a maximum and then go down from there. So find yourself a maximum and then just use that for the phase shift. So if I view this as my starting point for my cosine function, then I'm going to say shift it 3 pi over 4 to the right, and then the plus 5. So when we write these equations, there are always multiple possibilities of what we could write. You just got to find one of them that works. On the assessments, we will offer bonus points if you're able to find more than one. That would be correct. All right, so let's try this next one. So we're always going to start by drawing in the midline. So this one we see hasn't been vertically shifted. The midline is the x-axis. But we can find amplitude goes from 0 up to 10. So our amplitude here equals 10. Our vertical shift, or our k value, our midline, those all refer to the same thing. And it's 0 because it hasn't shifted up or down at all. If we look for the period, so if we start at this maximum and trace a 1 full cycle, so until we get back to the maximum, that's 4 pi. That's what it takes from 0 to 4 pi. So the period equals 4 pi. So then our b value is going to be 2 pi divided by the period, which is 4 pi. And so we're going to get 1/2 for the b value that goes into our equation. Since we're starting on a high like that, we'll think of it as a cosine function. So amplitude times the cosine, b value, and then x minus h. But since we don't need a phase shift, we'll just have x. And then there's no vertical shift, so we don't need a k value either. That's our equation. Now let's write another one if we view this as a sine function. So if we view this as a sine function, we'd have to give it a phase shift. Sine function starts on the midline and then heads up to the maximum. So this would be 3 pi right here. So we could say amplitude of 10 sine of 1/2 times x minus 3 pi. That would also work. All right, writing the equations, and one more example here. So we've got midline. Always start there. So we see our midline is down at -6. From -6, it goes up to 0. So that's 6 for the amplitude, or from -6 down to -12. So amplitude equals 6 here. Our vertical shift, or midline, our k value is going to equal -6 for the period. So if we start at this minimum and come back to a minimum, it takes from 0 to 2 pi over 3. So our period equals 2 pi over 3. So then we have to use that to find our b value. So b is going to equal 2 pi divided by 2 pi over 3. But we don't divide when fractions are involved. Instead, we multiply by the reciprocal. So instead of dividing by 2 pi over 3, we multiply by 3 over 2 pi. So we get a b value of 3. Because remember, period does not go into the equation. The b value does. And that's one of the biggest mistakes that students make on these problems. Remember, you got to solve for b. This is the number that goes into the equation. Period is not found in the equation ever. All right, so now we've got to think about, are we using a sine or a cosine function here? So we could view it as a negative cosine function since we're starting down as a minimum. So we could give it a -6 out front. Cosine b value. We wouldn't need a phase shift for that, but we do need to vertically move it down 6. Or we could view it as a sine function that starts here with a phase shift of pi6. So we could say +6 times sine b value x minus pi over 6. And we still have that -6 on the outside. Because if we start here, we're going up, down, over, that would be a sine function from there. So there's always more than one possibility. Challenge yourself to see if you can write both a sine and a cosine for each one you do.